Hello, everyone. Welcome to the last session of Silicon Valley Code Camp 2018. How was Code Camp so far? Great. So it's the last session, so you guys are really dedicated. You must really want to know about interfacing. Hope I can do you justice. How many C programmers? Oh, cool. So I've written most of these slides assuming C programming experience, and C++, fine. And there are lots of slides on Lua, and my guarantee is that after this session, if you are a professional C++ programmer, you should be able to write a Lua program fairly easily, or your money back from this session. No. So it's only an introduction to the interfacing techniques. I'll go through different techniques some other languages use as well. But you may want to dig deeper into each of them. There's still a lot more to do in these fields. Why would you want to do this? If you're here, you probably have some problem you're dealing with. But in general, it is the combination of these two worlds, where one is easy to develop, and the other is very powerful, close to operating system and hardware. And the other problem that I run into is that there are lots of different languages that solve on one particular problem that's really solid in one area, and there may be many modules. How do you make them talk to each other? And from my own experience, I was working in a hardware startup, and there was some Go code, and there was hardware stuff that was done in C. And at that point, I was not aware of the C-Go interface, and because of the time pressure, we just did some hacks to get that working. But at my current company, we have a manufacturing facility and network testing that we need to do. So there was some Lua code and some C raw socket-based code that would basically, without any IP routing, find other clients and servers and send network packets and test the network connections. And that's when I wrote a raw socket interface from C to Lua, and then wrote a Lua program that kind of did all the heavy lifting in terms of sending packets out, checking the responses back, and then detecting a connection between these two devices, and then sending a lot of traffic through it. We won't mention system or exec here. So that was my interest in this particular problem. You might ask, why did you choose Lua? It is a very small, very embeddable language. In my case, I was working on an operating system that was at least 15 years old. Most of the current software would not just even compile. So I was able to just download Lua. It's about 60,000 lines of code, somewhere around there, and just make and run Lua, and you have a scripting language. Even on an archaic operating system, that was a benefit of it. And it has a C-based syntax. It's written in C. So now we'll look at Lua a little bit more. Like I said, it has a C-based syntax. Also, Lua JIT is a just-in-time compiler that claims it makes it the fastest scripting language today. It's also dynamically typed. It's a garbage collected language. So there are 8 basic types. The first 4 you're probably familiar with. We won't talk about thread at all in this presentation, but we'll focus on function and table. That'll help you to get most of the value out of Lua. We'll talk about user data a little bit also in the next few slides. If you're coming from C-based language, even JavaScript or something like that, one of the first things that tripped me up was that comments start with double dashes. Lua also has first-class functions, which means you can assign a function to a name and pass functions around. Many of the scripting languages today are able to do that as well. One other difference from C is that array is not a basic type. Lua has support for packages, but it's done through table. Table is the only data structure available on Lua. It's like so no other data structures types are available in Lua. It's just tables. We'll talk about tables in more detail later. User data is like in C, you have user data pointers that you pass around from library to library without modifying. User data is similar. You don't get many Lua operations on user data, but it's garbage collected. So you can from your C program you can set a structure or a pointer and send that as a user data to Lua, and then you can get it back in the next call. Other thing to note is that string is not null terminated. Strings in Lua is stored with the length first and then the string. So that makes it possible to put any kind of arbitrary binary data into a Lua string. Lua is multi-paradigm. You can also do functional and object-oriented programming using Lua. Secondly, it's an extension language and extensible language. By extension language, I was talking to Tom before. He used, I think, Lua as an extension language where your C program or C++ program can call Lua and use Lua libraries as an extension of your program, or read as configuration files from using Lua. On the other side, with C, you can write extra libraries that Lua does not have yet, and make it, and that makes it an extensible language. Quick examples of Hello World program. It's just a print, just a print with a string, and the second line is a comment. Quick and dirty Fizz Buzz program. It's also fairly self-explanatory, I think. So looking at the control structures, it's a fairly conventional set: if, while, repeat, and for. If, while, and for ends with an end keyword. Repeat ends with an until. Other things to note is that break and return should be at the end of the block. It should always be at the end of a block. You cannot have it in the middle. So if you do, it's a syntax error. You have to rewrite it such that it's at the end. There is no next or continue, no switch case, no ternary operator. Let's look at some quick examples. This is a for loop that goes from 10 to 1, decrementing 1 at each time. You saw a previous example where the last expression is optional. If you just write I equal 1 to 10, it will go from 1 to 10, incrementing 1 at a time. And it just prints. You can also loop through all the values of array A using I pairs, and then you can get the key and value in I and V with that. Fairly self-explanatory. If you have keys, go through the keys of a table T, you can just do pairs. The while loop is also fairly straightforward. Now, Lua function can be defined either in Lua or C. There is an example of a function in Lua. It can return multiple values. Lua function can have variable number of arguments. Like I said before, it's also first-class functions. Lua has support for lexical scoping and closures. So let's look at an example of a function. Let's say function f takes a and b. if you call that with just one parameter, with a 3, A gets assigned 3, and there is no, B is assigned nil. With 2 parameters, it works as we expect, but if you pass more, it'll just discard the last one or any subsequent parameters. Here is a library function example that returns multiple values. There is no named parameter support in Lua language, but if you want to do that, you can use a table to send that to the function. Here's an example of a variadic or variable argument in Lua. The thing to note is that function is really anonymous in Lua. It means that the code is not tied to the name. That leads to interesting applications where you can assign a variable, a different variable to print. So now A is a table with element P which points to print. You may not want to do this particular scenario. It's just an example of what you can do. A.P is now print, so that prints hello world. Now you can assign print to the sign function. Yeah. Yeah. Then you can do that, and then you assign sign again back to print. So now you have swapped basically sign and print. There may be particular cases where you want to kind of override some function so that the user has only a limited set of Lua functions. That may be something you want to do. I'm just telling you that this is what you can do. So this is a state machine that runs through different state functions that represent different states, and it just runs through them, and all these functions are assigned the variable inside that table. The state fns here is a table with do start state and the rest being functions assigned for each of the states. If something is not clear, please stop me, or if you don't get my accent.
The interfacing with the libraries, I'm just curious when you're going to cover that.
Yes, fairly soon. So the closure example, if you have done it, most of the high-level languages now support closures. So this is basically a function returning an anonymous function that has access to the local variables in the first function. So when new counter C1 calls new counter, C1 is new counter's return value, and when you call the first print, I gets to 1, and the second time it gets to 2. Even though when it's lexical scoping, when it gets there, even though that variable is not available, typically here it has access to that variable I. In Lua, it's called an app value.
So yesterday in Douglas Crawford's talk, first thing in the morning, he was saying this is the right way to do generators, and the code is exactly the same, okay, as what you were showing in Lua.
Oh, okay. I take most of the examples from the Lua.
It just happens there's a strong correspondence.
Oh, okay, cool. Looking a little bit more deeper at the Lua tables, it's the only data structure, like I said before, it's like associative arrays. Simple arrays are special cases where the index is basically the key. This is used for packages and for object-oriented programming as well. So in Perl, if you have an array and you set the millionth or the billionth index to 1, Perl will crash because there's not enough memory. But in Lua, it knows to create only one entry in the table and will set just that. I just tested that on recently to Perl. I started the Perl debugger and set a variable like that. It crashed right away. In Lua, it's just one entry. Some of the idiomatic ways of doing Lua So instead of writing a long if statement, Lua recommends simple and yes, and an or connected statements. That's a way to clone a small table and use next to check if the table is empty. To append to an array, you have hash t that gets the length, and then append 1 to that. Did I mention that array starts at 1? Oh, probably not. So since that's another difference from C, is that since arrays are basically tables with key as indexes, the arrays always starts with 1. For package support, it's implemented using tables. So there's a typical, there's a Lua path environment variable you can set, but this is not directories that it will go through, but it's basically regular expression of where the Lua can be. You just basically require a Lua function. It'll take that from Lua path. You can also set the same path using package.path and C path for the C code. Yeah, if you are implementing packages, the way to ensure privacy is to return a table at the end of the package. That's very similar to the JavaScript module pattern. Okay, so this is getting deeper into Lua. Lua is written, uses a handwritten scanner. It doesn't use a YAC-based parser. And it also has a register-based virtual machine. And it emits instructions on the fly. The other thing is that like many other languages, it also internalizes strings, which means strings are immutable. So tables, like I said before, it's key value pairs. But in the recent implementation, they have changed it such that smaller values of an array is assigned a certain amount of memory, and it is directly stored as a buffer instead of key value pairs. But it is smart enough to know when you're using table and when you're using table as an array. So there are two ways of integrating Lua and C. You can use Lua as a library inside of your C function, or you can extend Lua with C libraries. Both of them uses C API. Now there are two different challenges. One is that Lua is a dynamic type system, whereas C has a static type system. Other one is that the memory management in C is manual. You guys all know this, but you have to do malloc and free yourself. In C, all of this is garbage collected. So how do you bridge this gap between these two worlds? Lua's answer is using a stack between Lua and C. Basically, you exchange values between Lua and C by pushing to the stack and popping from the stack. And before you write to the stack, always make sure that there is enough room in the stack. This stack is per call. It's not a per Lua stack. It's per call into there is a stack per the C call that you're making from Lua. For each Lua type, there is a push operation, push function. Lua state is a global variable that you get when you open a library, initializes Lua, and then you pass that around. Lua does not keep any global information. It just puts it in the Lua state function, Lua state data structure. And these are the different functions to push different kinds of Lua types onto the stack. The difference between push L string and string is that in the second case, the first case passes the length, and so that takes care of the case where you want to just push the C string as it is to Lua without specifying the length. Like I said before, library defines no global variables, keeps all its state in Lua state. So you can also read and write Lua global variables. We'll see an example shortly. You can also call Lua functions. You can run small pieces of Lua code. Also, when you write your C library that you're going to use as a Lua extension, you have to register the C functions. The register functions have changed in the recent versions, but yeah, you can embed Lua in your C code. We talked about that a little bit earlier. So if you have a configuration file or any kind of script that you can use Lua to parse that instead of. I think this is a very interesting application for Lua, where you don't need to have configuration different kinds of configuration, reading libraries, or the parsing. There may be lots of code to just parse configuration files. You could remove all that and just use Lua as your configuration language. So an example where, let's say you have a width and height in a config file. This code can read that into your C code. Basically, yeah, you can see the functions there. On the other side, you can also call C from Lua. This is what I did with my network testing the application, where there was no support for, there was no raw socket Lua library. So that's what I wrote. Wrote a raw socket C wrapper that converted the C, converted calls from Lua into the C raw socket calls. You cannot call any C function from Lua. You have to follow some protocols, which is dealing with the stack, getting the Lua variables and converting that into your data structures. You can also query from the stack, and that's what you would do when you're calling C from Lua. To get value from the stack, there are these functions that you can use to convert convert from Lua to C. One of the things to note here is that if you Lua does not do checks on the type on its own. So you have to make sure that the type that you are sending from Lua, your Lua side, is a type that you're reading from the C side. So if you send a string and try to read it, as number from the C side, it might give you garbage. So this is assuming that you have control on both sides. So other ways of doing that, similar things. Swig is a very popular way of doing that. That's also foreign function interface. Like I said before, we don't talk about system or exec. So an example of Swig with Python, you can convert Swig into you can convert the C into Python callable functions. So now we'll look at Ruby a little bit. I won't get into as much detail about Ruby as we did about Lua. Any more questions about the Lua side?
When you call back and forth, when you are in Lua, go to C and from C back to Lua.
Yep. Oh, both sides is stack. So you can return values from C to Lua as well. So you can even, there are functions to create even a table from C, and you can send that whole table back in the return value from the C code.
And then Lua puts it in its space.
Yes, yes.
So you actually move data around. It doesn't, so when, from the static part, it goes then into the dynamic managed memory space, but it's copied there.
Yes.
Created by
I'm not sure if, Lua is very smart in doing its memory management. I don't know if it's really doing a deep copy or just changing the pointers such that.
Because otherwise your stack is like cheap, whereas the memory otherwise is managed. Except it's changed.
It is not the stack that the C stack we think about. This is a stack that Lua has created for the communication.
Yes, but that data has to go away then.
In garbage, when it's garbage collected. Yes.
Copy
Yes, correct.
recreated in the
Correct.
dynamic space of Lua.
Okay, okay.
And so that's why there's accessors for the stack.
Yeah, you guys, all these constructs get and repeat and push values.
Yeah.
Yeah, but I think it's like a common pattern of you want to be able to enable like power users to write scripts, and so your application will execute the script, but then you have pre-populated the globals with a table that it looks like a package. You know, it's basically an
Yeah.
object with a bunch of functions that can be called by the script. And so it's going to call back into your application to do stuff. And so that works pretty nicely.
Cool. But just to give you a quick overview, Ruby on Rails is very popular. Ruby is considered a purely object-oriented scripting language. It's also dynamically typed, and it's very popular for meta programming as well. Everything is an object. There are 3 levels of access. One of the things about Ruby and Ruby on Rails is that they're very strict on naming conventions. One of the things that's very interesting is that you can write entire Ruby programs directly in C. Ruby has a very large, comprehensive C API. So the type of all Ruby variables is called value. And so like in Lua, where the way the C functions get called from Lua, I don't think I mentioned this, is through DL open. So you create, when you compile it, you create a .so or a dynamic share object, and then you dynamically load it using DL open. You don't have to do any of that. Lua does that for you. You just have to create .so. It's similar in Ruby also, and you just need to require the name in Ruby. A quick look at the control structures. It's similar to before, and if, while, and until, and also it also has a single line format. So if you're not familiar with Ruby, this is an example of a class that shows different kinds of usages. I know there's one Ruby program. Any other Ruby programmers? Oh, okay, cool. I'd like to discuss with you later on what your interest in interfacing. So yeah, maybe we can help each other more. And this you can also run arbitrary Ruby expressions like running an eval. Of course, after checking the user input. This is, I think, is very powerful in itself. Like I said before, value is an important concept when you are interfacing Ruby and C. The Ruby, this object, this value it's not pointing to any arbitrary structure, it's pointing to Ruby object. And it may not be a pointer at times. Sometimes if it can be stored directly inside value, it is stored inside value. And there are lots of conversion macros that convert from Ruby into C. And also all the C functions callable from Ruby must return value. So if you have a C data structure, to convert that into value, these are the functions. Basically, you just pass them. You just pass this function, your C function, and then you get a value which is a Ruby object. Now you can send that value to other Ruby C API.
Is your code there supposed to be C code or Ruby code?
Oh, this is all C.
Okay. Are you going to show, you'll show it from the Ruby side? Ruby calling a C library.
Sorry, I don't have an example of that. Yeah, and then you could call it similar to any Ruby call you would make. The require, and then you get a variable, and then you just use that as a Ruby code.
So you're only going from the C side to Ruby. You're not going from Ruby to C.
That's what I'm going to do. I want to do next is I want to be so. That's one of the things that I want to do is from Ruby be able to connect to Yak or any parser like that and be able to compile from the web interface. That's
Next in the presentation or next in your
not in the presentation. I'm sorry. I don't have more on the Ruby C side anymore. This is the end of the presentation. That's what I want to do personally. I'm not there yet.